Hello friends, welcome back. In the last lecture, we discussed about the correlation. It's correlation between two variables. How much they are correlated, how the demand and supply are correlated, how the population and food demand is correlated, how speed and the distance covered is correlated. Now in continuation, we are going to discuss one more problem on correlation. The data is given to you. In order to save time, the problem already I have written on the sheet. Now in last problem, we used the correlation coefficient formula. So this was the formula. Correlation, this is the coefficient of correlation formula. Here what we have done, we found capital X, capital Y and summation xy, under root of summation x square, summation y square. Only three things are required: summation x square, summation y square and summation xy. But in this problem, I used mean deviation. This capital X is the mean deviation in X. Capital Y is the mean deviation in Y. X minus x bar is the mean of small x, mean of this small x, and y bar is the mean of small y. And capital X, you may use u and v in place of capital X and capital Y also. Now x minus x bar is the mean of x entries, that is 65, y minus 66 is the mean of y values. So using mean deviation, we use this shortcut formula. Now, but many times what happens, the mean of the data, mean of x and mean of y are not real, are not integers, are not positive integer or integers. In that case, the further calculation part becomes difficult. Unnecessary, we have to press the buttons of the calculator and we have to get it. It is a wastage of time. Instead of using mean deviation, without mean deviation you can solve it. Just in order to make it more effective, we are using mean deviation, and it is good habit to use mean deviation. Then next problem, immediate next problem. There, the mean values of x and y, both or one of them, is not an integer. In terms of decimal point, we have to write, we may get the x bar, mean of x, or y bar, mean of y, or both of them. In that case, you may take help of assumed mean also. Means you have to assume a particular mean, and just you go ahead. Very quickly, the next problem we are going to solve. Find the coefficient of correlation, means R, from the following data. Okay, this data is given. This data you can relate with any variables or any real life problems. This x and y are given. Now what I am going to do? If you take y bar or mean of y or mean of x, you may get in terms of fraction, in terms of decimal point we have to have the value, and then x minus x bar, or here we have written x, now I am writing u, x minus x bar and y minus y bar. If x bar and y bar or any one of them is in terms of fraction, then calculation will be little bit tedious. So in order to avoid it, we can take help of assumed mean also. Assumed mean means what? You can take any particular value which fits the data, and it is fully dependent on us. My assumed mean may be different than that of you. Now this data is given, x and y data is given to you. Now what I am going to do, let assume min. In previous problem the actual min I used, assume min x bar. Okay, assume min x bar, you can take 152, you can take 158, you can take 160 also. So here I am taking 150, assume min is 150, and assume min in y, assume min in y, okay, I am taking 160, I am taking 160, is it? So in place of this 150 and 160, you can take any value nearby these numbers. Nearby this, you can take 152 in place of 150. You can take 160 also. It is your choice, but it should be near to these values. Okay, to make it more effective. Now, the x minus x bar we are going to calculate. The u is x minus x bar, v is y minus y bar. In previous problem I used, instead of u and v, capital X and capital Y. In order to differentiate it, just I have used here u and v. You may use capital X and capital Y also. Here n, in this formula n is there, number of entries 1, 2, 3, 4, 5, 6, 7. Here n is what? 7. N is 7. Okay. Now here u and v I am going to find, u and v I am going to find. X minus x bar 152, here be more specific, I am writing here 150, and v is equal to y minus 160. Okay, these are the assumed. Now 152 minus 150 is 2, 158 minus this is 8, 169 minus this is 19, this minus this is 132, this minus this is 10, and this minus this is 16, 182 minus this is 32. Okay, this way. Now y minus y, 198 minus 160 is what? 38. Then this minus this is what? 18. This minus this is 7. This minus this is minus 8. This minus this is 20, this minus this is 10, and 162 minus this is 2. Okay, values of u and v before. Now, in this formula of coefficient of correlation, this R is a coefficient of correlation. Okay, in this formula, u bar is also required. U bar is the actual mean of, okay, just I am writing here summation of u bar. Summation of u. Okay, the summation of u is sum of all values of u, and summation of v is 119, and summation of v is what? 87. Is what? 87. In this way, summation we have calculated, summation of u and summation of v. Now, here u bar equal to what? It is summation of u, sum of all values of u by n. It is 119 by 7, and 119 by 7 using calculator, it is what? 17. Okay, 7 4 and 7 7s are 90. Okay, then v bar is equal to summation of v by n. Summation of v is 87, and 87 by 7 is what? It is 12.428. 12.428. Okay, you can write up to 3 decimal places, up to 4 decimal places, it is your choice. The u bar and v bar I have calculated. It requires u into v also. So u into v means product of u and v. So 38 into 2 is what? 76. 18 into 8. 18 into 8 is what? 144. Then 133, directly writing. Okay, minus 256. Will not waste our time on finding out the values on using calculator, 160 and 64. and summation of uv is required. The summation of u into v means sum of all values of this is 521. Okay. Summation u square is also required, v square is also required. The u square means the square of u. 2 square is 4, 8 square is 64, 19 square is what? 361. Is it? Then this 82 minus this is 32 only, no? Okay. 361, then 1024, 100, 16 square is 256 and 32 square is 1024. And summation of u square I want in the formula. Summation of u square is required. The summation of u square directly I am writing 2833. Sum of all. Now v square. 38 square is what? 38 square is 1444. 18 square is 324. 7 square is 49. Minus 8 square is 64. 20 square is 400. 10 square is 100. And 2 square is 4. The summation of v square is also required. The summation of v square value is 2385. Okay, in this way, u into v, u square, v square, their summation we have calculated. Now, using this formula is coefficient of correlation. Coefficient of correlation are, this formula I am not going to repeat it, just I am going to put the values and get the value of r. Summation u into v is what? 521 minus n. N is what? 7 multiplied by u bar into v bar. U bar is what? 17 and v bar is what? 12.428. Is it? Once again, this is summation uv, 7 is n, u bar is, what is u bar? 17 and v bar is 12.428. This divided by summation u square is 2833 minus n is 7 multiplied by u bar square is 17 square, this multiplied by under root summation v square is 2385 minus n v bar square, n is 7 and v bar square is what? 12.428 square. Is it? And you try to evaluate it. Use calculator and get the value, and it will be minus 0.9322. Here we have negative correlation. We have negative correlation between these two, between x and y. We have negative correlation between these values of x and y. Okay, it may be related with the supply and demand, Okay, if supply increases, the demand decreases. If demand increases and supply decreases, like this. The coefficient of correlation means value of R we found. We have seen two problems. We discussed two problems. In first one, the actual mean I used, and here assumed mean I have used. And why did I do so here? Because it may be the case, it may be one of the possibilities that the mean of x values, that is x bar, or mean of y values, that is y bar, may be fraction. And if it is fraction, so your calculation will be very much, it will be lengthy, That's why assumed mean you can use. But when you use assumed mean, then you have to use this formula. When you use actual mean, then summation x, capital X into capital Y by summation of under root of summation of x square, under root of summation of y square you can use. So this is about the correlation between two variables. Correlation between two variables. Now we are going to discuss one more concept, that is regression. That is regression. And especially we'll be interested in the lines of regression. We'll be interested in the lines of regression. So why these lines of regressions are needed? When you take any decision, when engineers are going to take the decisions, why regression lines are plays a role? What is the role of regression line? When you deal with the statistics, when you deal with the data. See, if you are dealing with two data, X data and Y data, two variables you are having, two types of data you are having, and in these two data, and these two data, two variables are correlated up to our desire. These two variables are correlated. In that case, the prediction is possible. The prediction is possible, and the prediction can be done using line of regression. Okay, what is a line of regression? It is the best fit line in given data. It is the best fit line in the given data. So, suppose I'm giving an example how it is used in prediction. Suppose the demand and the availability. Demand and availability, or for example, previously I have given an example from in the year 2000 and up to 2020. We have the data for 20 years regarding food demand. The population in 2000 was this much, was 100 crore suppose, and the demand was food demand was X metric ton or 2000 metric ton, for example. In 2001, the population was 105 crores and demand was more than 2000 metric ton or 2050 metric ton. The gradually demand is being increased and population is also being increased. And you have the information or the data for last 20 years. Okay. And you need to predict the food demand for the year 2021 or 2022, 2023, 2024 and more than that. So how the planners, okay, they will plan. Suppose this is the population and this is the demand of food, okay, the food demand. Now when in 2020 it was, the population was 100 crore and the demand was 2000 metric ton. Is it? Then in next year the population and this demand like this. Okay, this type of data is available with you. This type of data is available with you. And we are going to predict the demand for coming years 2021 or 2022. So what to do? What the statisticians are doing, they are going to fit the line, that is the line of best fit. They are going to fit the line, and that line is somewhat closer to the maximum point. The line is somewhat close to the maximum point. That is what called the line of best fit. And once you get the line of best fit, then in the year this is up to 2020, you know. It is 135 crore population, and when the population will be 140 crores, you know, then the demand will be this. When the demand will be this much. Okay, this is the significance of best fit line. That is what called the line of regression. Means on the basis of available data, you can fit the line, and once you get the line of regression or line of best fit, then you may predict the future. You may predict the future demand in this case. So there are two types of things: the line of regression x on y and line of regression y on x. Line of regression x on y and line of regression y on x. Now, in regression, line of regression x on y, in the regression, is normally one problem in almost all the universities is asked on line of regression. You know, the line of one simple problem I am going to discuss. Okay, first of all, I am going to write line of regression y on x and line of regression x on y. Okay, I will tell you which line is better when you predict the thing. The formula, just I am going to write the formula: y minus y bar is equal to byx. This is subscriptive, x minus x bar, line of regression y on x, and line of regression x on y, x minus x bar, bxy, and y minus y. And what about byx and bxy? These are the regression coefficients. Okay, regression coefficients where bxy and byx are regression coefficients. And there is a typical formula to evaluate x bar and y bar. You can easily get from the given data, and the regression coefficients you can easily find as bxy, or regression coefficient x on y. Okay, that you can calculate using this covariance in xy. COV I am using for covariance. This divided by sigma y square. I tell you what is sigma y. Sigma y is the standard deviation in x in y, and byx, covariance in xy. This divided by sigma x square, where COV xy, this is the covariance in xy. Sigma y is the standard deviation in y. Standard deviation in y, and sigma x is standard deviation in x. Okay, only these things you have to remember for the line of regressions. Now, it's a very simple problem we are going to discuss very quickly. The problems on line of regression. So I will take few minutes to draw it. It will be more comfortable just if I use a scale. The question I am writing, Find first problem. Find the line of regression. Okay, lines of regression is line of regression x on y and y on x. Find the lines of regression for the following data. You can relate this data with any situation. Also find the value of y when the value of x is equal to 6. Value of x is equal to 6. Is it? Okay, this is a problem given to you. Very quickly, just I am going to, this data is given to you. Data is given x and y, 2, 3, 5, 7, 2, 3, 5, 7, then 9, 10, 12, 15, 9, 12, this is 12, 10, 9, 10, 12 and 15. Okay, these values of x are given. Values of x also I am going to have here. Just I am going to copy 2, 5, 8, 10, 12, 8, 10, 12, 14, 15 and 16. Okay, that this data is available. Find the line of regression for the following data. Also find the value of y when x equal to 6. This data is given. In examination you may be given any data. Now, we have to find line of regression. Just you concentrate on this. What does this require? This requires x bar and y bar, means mean values we have to find. Mean value of x, mean value of y we have to find. Then covariance also we have to find. Standard deviation also we have to find. Now, this I am going to solve this problem, and for this thing, this is the first is x, y, then here this I am making x square, y square and x into y. Okay, yes, you can use mean deviation or standard deviation also here. You can use mean deviation, standard deviation also. Now, first, second, how many entries are there? 1, 2, 3, 4, 5, 6, 7, 8. 8, 1, 2, 3, 4, 5, 6, 7 and 8. And for summation is one more row I am adding. Okay, in this way, this table we have formed. Now, the values of x and y directly I am going to copy 2, 3, 5, 7, 9, 2, 3, 5, 7, 9, 10, 12, 15, 10, 12, 15. Similarly, value of y 2, 5, 8, 10, 2, 5, 8, 10, 12, 14, 15, 12, 14, 15 and 16. Okay. Now x square. The value of x square, values of x square I am writing. X square means what? Square of this. 4, 9, 25, 49, 81, 100, 144 and 225. Okay. X square. Y square is what? 2 square is 4, 5 square, 8 square, 10 square, 12 square, 1 to 14 square. 14 square is 196, you know. 14 square is what? 196. It is 15 square 225 and 16 square is 256. X into y, product of these two, x and y. 2 into 2 is 4. 2 into 2 is 4. 3 into 5, 15, 40, 70. Then 12 into, this is 108. Is it? This is 140 and product of this 15 into 12. It is 180, no? And this is 160 plus 240, no? Okay, now the sum of xy is 797. Sum of y square is sum of xy. Sum of y square is 1014. Sum of x square is 3637 and sum of y is 82 and it is 63. This is sum of y, sum of x. Is it? It's very simple, straightforward. Now what is required here? Here we require x bar. Here I am going to calculate x bar. Okay, x bar is what? Summation x by n. Summation is 63 by 8. Okay, 63, 8. And it is what? 7.875. Y bar is required. Summation y by n. Summation y is 82 by 7 and it is 17.609. Okay, up to 2 decimal places you can write. This y bar and x bar we have calculated. Now it remains to find out value of bxy, byx. For bxy and byx, we want covariance. Then we will be finding sigma x and sigma y also. Sigma x, sigma y are standard deviation. Now the covariance of xy we are going to find. So write down the formula for covariance. Just I am writing here. So I am going to write here. Covariance of xy. Okay, the covariance of xy formula is what? Summation xy minus x bar y bar and this only this divided by n. This divided by n. Okay, this is the covariance formula. This you have to remember. Summation xy, where is summation xy? 797 by 8 NZ. X bar is what? X bar is this 7.875 multiplied by 17.609. Okay, and if you calculate it, the covariance I am going to write directly 18.906. 18.906. Okay, this is the covariance in x and y. Just formula is enough. So use the formula, put the value and get the answer like that. Covariance. Now sigma x, this is a standard deviation, and standard deviation square is the variance, but sigma x square directly I am writing. You can find out the sigma x and take the square, or sigma x square directly. Yes, I am using writing the formula for sigma x square. The sigma x square formula is what? Summation of x square by n minus x bar square. Summation x square is known to you 637 by 8 NZ, and x bar is known to you. Where is x bar? This is x bar is 7.875 and square of it. And sigma x square directly just I have the calculation and get it. The sigma x square value, if I am taking the value from here directly, you can use the calculator and get it. Sigma x square is 17.609. Now, sigma y square, similarly you can find summation y square by n minus y bar square. Replace x by y only in the formula. Summation y square is 1014 by 8. Summation y bar is what? 17.609 and square of it. Okay. Now the sigma y square, just I am going to write directly 21.687. Okay, this is the value of sigma y square. Just putting those values here, covariance sigma x square, sigma y square, and get the values of bxy or byx. Now bxy is equal to what? Covariance in xy 18.906 is divided by sigma y square is 21.687 and bxy is 0.8718. Similarly, byx is what? Covariance in xy is 18.906 and this divided by sigma x square. Sigma x square value is 17.609 and byx directly I am writing 1.07074. Okay. In this way all the values we have calculated. Now I am going to use the next sheet. Instead of using next sheet, I am writing here itself. Okay, here itself, or here in this portion I am going to write. Okay, it's formula. This I am going to give. This is 1 and this is 2. Now putting all values in 1 and 2, the 1 implies y minus y bar. What is y bar? Y bar is 17.609 is equal to byx. Byx, where is byx? Byx is what? This 1.074. X minus x bar. X bar is what? 7.875. Okay. So this is line of regression. Line of regression y on x. Line of regression y on x. You can simplify it further. You can multiply this by outside component and you can shift this on the right hand side and you can solve it further. This is the line of regression y on x. Now line of regression x on y. Equation 2 gives x minus x bar 7.875 is equal to bxy. Where is bxy? This is bxy. 0.8718 and y minus y bar. Y bar is what? 17.609. Okay, this is line of regression. In short, I am writing line of regression x on y. Okay, now the line of regression x on y, line of regression y on x we have found. What is the question? Find the lines of regression that we have done. Here one more part is there. Find the value of y when x equal to 6. Yes, for x equal to 6, the value is not known to you. For x equal to 6, value of y is not known to you. For x equal to 17, value of y is not known to you. For x equal to 18, value of y is not known to you. But you can find out the values of y for the values of x which are not present here, which are not known to you, which is not present in the table. So here in this problem, find the value of x, y when x equal to 6. So when you find value of y in x equal to, when x equal to 6, when you find value of y when x equal to 6, the preferably use line of regression y on x. Line of regression y on x. What is the reason behind it? Because this line is the best fit line. Line of x and line of y on x and x on y. The best fit line. That's why the many points or some points may not be on the line. That's why the approximate value you may get, approximate value of y or value of x you will be getting. That's why when value of y is asked, when x equal to 6, use line of regression of y on x equation. The line of regression y on x equation, this is equation 3. Here put x equal to 6 in equation 3. In equation 3, if you put x equal to 6 in equation 3, it will be y minus 17.609 is equal to 1.074 and x is 6, 7.875, is it? I have substituted x equal to 6 here. Therefore, y is equal to, directly writing, therefore y is equal to, the value of y is equal to 8.237. See here, for x equal to 6, value of y is not known, but once you get the line of regression y on x, the put x equal to 6 in the line of regression y on x, then you will get value of y. If in this problem it is not asked, but in the examination it is asked like this: find value of x when x equal to 5. Find value of x when y equal to 13. 13 is absent. Find value of x when y equal to 13. In that case, choose the line of regression x on y and put value of y there, which is 13, and get the value of x in this way. In this way, we solve the problem on line of regression. So once again, I am going to wrap up shortly in minimum time. Find the line of regression for the following data. Also find value of y when x is given. Okay, this data is given. This is copied from here. X square, y square, xy columns that I have done. X bar, y bar required, mean values are required that we found. Here covariance separately I have calculated. Standard deviation square I have calculated. Sigma x is the standard deviation in x. Its square I have calculated. Or if you find sigma x only, take square root of right hand side. Then standard deviation in y we have calculated. Putting values here in this formula. Okay, the bxy regression coefficient, byx another regression coefficient that we found, putting values here, and once you get bxy and byx, the putting in these two equations so as to get line of regression of y on x and x on y. And here one more additional thing is asked: for x equal to 6, what is value of y? The value of y is asked. Use line of regression y on x. So this equation I am using. To put x equal to 6 here, put x equal to 6 here and get the value of y. If value of y is given to you and value of x is asked to find, to put here value of y and get the value of x in this way. So we stop here. One more thing I want to share with you, that here the data is in terms of x and y it is given. These small numbers are given. If numbers are big, 100, 200, 300, 500, 600, 700, like that, 1000, it becomes little bit inconvenient to have the square of it and take sum of it. unnecessary, just you have to have the calculation. In that case, you can use the assumed mean also. You can use actual mean also. And just you replace x and y by u and v and try to solve it. Okay, the concept is same. You can use mean deviation, you can use assumed mean deviation, and you can solve it. So I think you have understood it. So we stop here. Thank you very much.